Hey guys, so in this video, we're going to be going through some important vocabulary terms pertaining to angles. So you should have this page in your OneNote. The definitions are already in there for you, so there's not too much that you have to type. We're going to focus mostly on, again, just kind of discussing the definitions and then looking at the symbols and drawings for each of these. Okay, so if we're talking about angles, it makes sense to start off with our first term just being an angle, right? You guys might, I'm sure you know what an angle is, right? But in terms of geometry, the way we define this is it's a geometric shape that is formed by two rays, right? And you guys want to think back to our first vocab chart that we started with on like day 3 of the class, right? What was a ray, right? Well, let's draw one in. It was a piece of a line with one endpoint going through some other point, right? Maybe we call this E and call that G, right? Well, an angle is just made up of two rays with the same endpoint, right? So maybe it would look like this. Maybe we name this other ray, ray EO. Okay, so again, just like we said when we have rays, the way we name them actually matters. It's the same thing with angles here. So there's actually, so if we take this angle, right, and when we say angle, another way to think about it, it's formed by the rotation of these rays, right? So the rotation that's basically made in the space that's between those rays. So that's the angle that we're talking about. And if we want to name this, there's two ways. So just like, and again, I'm just going to write this on the side, like when we named maybe a line like this, A and B, when we wrote it symbolically, we put AB and then that little symbol on the top, right? That told us that what we're talking about is a line. So we have something similar for angles, and it just looks like this. So we're going to say angle, and we could call this angle GEO or angle OEG. Now you guys want to think about, again, these are the two ways that you can name it. So what's similar? What is common between those two ways, right? Maybe you're noticing that point E was always in the middle, right? That's going to be the most important thing when we're naming these. So I'm going to put this in, and I'm going to say vertex must be middle. All right, and if you take a look, our next term is going to be vertex, so we'll talk about what that means. But for now, actually, let's just say it. So a vertex is the common point where the two rays meet, right? So if we look back to this picture, point E has to be the vertex, right? It's the point that both the green ray and the blue ray share. So point E is our vertex, and it always has to be in the middle when we name it. And the reason is, I like to think of this naming, right? So calling it GEO or OEG, that gives us direction, right? That tells us, and let me get like pink, that says start at point G, go down to point E, and over to point O. That gives us our angle. And same thing, O to E to G. If we name this maybe EGO, that would actually look something like this, and that would not be the same angle. So that's the important concept here. All right, so for vertex, again, we talked about it. The most important thing is just to know that it's the point where two rays meet, and maybe we can just draw another one in there. I'm not going to label everything. I'm just going to say that this is our vertex. Okay, and similar to how we had to name points before, right? Vertex is always going to be a point. Maybe we'll call this point V. If we want to name it, we just say a little dot with a V, or we can actually write out point V. All right, let's keep moving. So then we're talking about angle measures, right? Think about what it means to measure something, right? You're measuring maybe the length of your table or the height of your car, something like that. So when we talk about angle measure, it's actually the amount of rotation between both of the rays. right? So let's say, I guess I can just draw this same picture in, right? And again, I'm not going to label it because we're not actually talking about the points, but we just said that the angle is actually the amount of rotation inside there. That's what tells us the angle. So maybe this is 30 degrees, right? And we always measure it in degrees. It's the important thing here, for this class at least, right? So 30 degrees, you might have used a protractor before, right? That's how to actually physically find the angle measure of something. But in this case, in this class at least, since we're virtual, we won't be using any protractors, but that's what their purpose is. All right, then if we take a look at term number 28, so congruent angles. So just like we were talking about, back to maybe think back to segment addition, right? This word congruent, that's going to be a super, super important term that comes up throughout the course. You want to make sure you're comfortable with knowing what that means, right? Congruent, anything congruent means exactly the same. So same length, same angle measure, same size, something like that. So in the case of congruent angles, they're just angles with the same measure, right? So let's draw one in here. Maybe we make it look like this. Again, there's our two rays. And I'm going to do this on purpose. So let's say we measured these with our protractor, and both of them came to, well, that's not going to be 30. Maybe we make it 120 degrees for each of these, right? This is just hypothetical. Even though you can see that one is kind of oriented up and then one's more on its side, it doesn't matter what their orientation is. As long as these angle measures are the same, we know that these two angles are congruent. So usually you'll see them put a tick mark on that arc to show that those two angles are congruent. All right, and let's say these two angles had their vertex as point F and point G. We could actually name these angles angle F and angle G. And the important thing to be able to do here is put in our congruent symbol. All right, just like we learned before, it's just an equal sign with a squiggle on top. That's always means congruence. So whatever's on the two sides of it, in this case, two angles, that's telling us these two angles are congruent. Okay, now actually this brings up a question that we didn't talk about up when we learned how to name angles or label angles. In this case, we can just name these with one point, so angle F and angle G, because they don't share any of the same points, right? They don't share any of the same points, so it's fine to label them with just one letter. Whereas, and maybe we can come over here on the side just to kind of see a different example, maybe we saw something like this. Maybe this was called point X, right? We could not call, maybe we were looking for the measure of this angle in red. We could not just call that angle X, right? And maybe you're seeing Y, right? Well, angle X, multiple angles share that same vertex. So when we say angle X, we could be talking about this one in green, this entire big one in green, or possibly the one that we want in red. So in something like, in a case like this, let me just put random letters in here. In order to name this red one specifically, we would have to call this angle, again, YXZ, or angle ZXY. All right, just like we said in the first example, it's always going to have the vertex as our middle letter. Just a side note. Okay, so then our next term, interior angles. All right, and this will come up a lot more later in the course, but these are simply just angles that are inside of some closed shape, right? So let's say we had these three lines intersecting, right? Hopefully you agree with me that when all of these three lines intersect, we get a closed-in figure there, which, hint, hint, you guys should know, we call that a polygon, right? It's just a flat figure that's closed in with straight sides. But that's not what we're talking about. We're talking about interior angles. Interior angles are just going to be any of the angles that are formed inside here. So there's one, oops, there's one, there's 2, and there's 3. Maybe I'll just give them numbers. So those are all examples of interior angles. And then similar, I guess I'll draw the same picture here so we can compare. It's not exactly the same, but it's close. Actually, it's not going to be clear enough. Let me make it like this. I want to make the inside part smaller. So exterior angles then are any of the angles outside of the shape. So maybe I'll switch to yellow. So here's 1, 2, 3, 4, and so on. All right, so all you have to know is that it's going to be any of the angles outside of a closed-in shape. All right, so terms 31, 32, 33, and maybe 34, I'm sure that you guys have heard of before. So we'll kind of talk about these briefly. So 31 is an acute angle, right? The big thing here is it's an angle with a measure between 0 and 90 degrees, right? So maybe it looks something like this, right? That's definitely less than 90 degrees. Maybe we can call this, let's say it's 40 degrees. That would be an example of an acute angle. An obtuse angle, something like this, right? Greater than 90 degrees. Maybe this one is 140 degrees. All right, so that's any angle with a measure between 90 and 180. Right angle, that's our favorite. We talk about these a lot. So if we have a right angle, that's going to be measuring exactly 90 degrees. So you guys have seen we've been putting the arcs in here, like the rounded mark to show the angle we're talking about. When we have a right angle, we actually can put a box in there. And at this point, that is enough to tell us that's a right angle. We don't even have to write 90 degrees, but we can for this case, right? But anytime you see that box in the corner, that tells you you have a right angle which measures exactly 90 degrees. 34 is called a straight angle. And this might have heard of this before. If not, that's okay. It's actually going to be an angle that measures exactly 180 degrees. Right? So think about like an obtuse angle. It's actually going to be, straight angle is a perfectly straight line. And the angle that's formed is really like the rotation right there. So 180 degrees. Again, right angle has to be exactly 90. Straight angle has to be exactly 180. Obtuse and acute can be between 90 and 0 and between 90 and 180. Okay. Then if we talk about number 35, so angle bisector. So this is just a ray or a line, right, that cuts an angle into 2 equal parts. And you guys should have known that, right, from the word bisector. Throughout geo, anytime we hear bisector, it means 2 equal parts. All right, so let's see if we can draw in a picture here. All right, so let's see. Let's first draw an angle. Maybe we'll call this angle GEO, just like we were saying. So angle GEO. Now let's put an angle bisector in. Maybe we'll make it a ray. So it would be something like this. All right, let's just call this EM maybe. So think back to what we had said before. Think about how we said 2, like so, maybe on the side. So think back to segments. So we had this segment. Maybe we said this line was a segment bisector, right? When we had a segment bisector, we knew that, well, this left piece, this left segment, and this right segment will be equal lengths. And that's why you put those congruence marks in, right? The tick marks. So that's actually what we're going to do in the angles. But just like we showed earlier, angles always have the arc, and then we can represent it with our tick mark in that arc. So think about how we would name these 2 angles, right? Again, we name them with the 3 points that make them. The middle one, the vertex, always has to be the middle letter. So if we want to label this yellow angle, we could call that angle GEM. Whoops. Okay, so that would be our yellow angle. And then let's say we wanted to name the green angle. So we could call that angle OEM. And that's our green one. All right, and just like we said, since these two angles, right, the bisector, or ray EM, the one in the middle, the reason it's breaking, the reason we know it's an angle bisector is because the other two angles, so GEM and OEM, are going to be the same measure, right? Or in other words, they have the same angle measure, right? So they're going to be congruent. So we could put that congruence mark in. All right, let's see. Complementary angles for number 36 and supplementary angles for number 37. These are going to be really important ones. We're actually going to spend some time talking about those as well. So complementary angles, right? So that plural tells us more than one. Complementary angles are actually two, or I guess I really could say two or more angles. But the big thing here is the fact that together, these two or more angles will add up to exactly 90 degrees, right? That's the big thing that makes these special. So again, add up to 90 degrees tells me, well, I better draw in a right angle first because we know that's exactly 90 degrees. And then maybe we draw this ray in. So this first angle on the top, maybe we say this is 50. Well, in order for these to be complementary, right, add to 90, the smaller one down here has to be 40 degrees. Okay, so let's see, just to get us some more practice naming, let me put some labels here. So maybe A, B, C, and D. All right, so we can say angle ABD, that's our 50 degrees, and angle, I should write and angle DBC, maybe we can call it, are complementary. And just to be, for the sake of time, I'm just going to write are comp. Right, so those two angles are complementary. Then if we look down to number 37, so supplementary angles, again, two or more angles who add up to 180 degrees. Right, so again, we said a straight angle is exactly 180 degrees. So I know I'm going to have to start with that. And then maybe we put this in here. So let's say this angle is, oops, maybe this is 120 degrees. Then this one on the left has to be 60 degrees. And maybe to look at this one a little bit differently, another way we can name angles is with numbers. So maybe they call that one angle 5, and they call that one angle 6, for instance, right? Instead of naming them with points, we might name them with a number. And again, just like with a line, remember we said if we had a line, we could name it with 2 points, line AB, or sometimes they would put like a lowercase cursive letter, and we could call that line M as our shortcut. So if they give us numbers, that's essentially a shortcut for naming angles. So we can say angle 5 and angle 6 are supplementary. So I'm going to just do SUPP. All right, couple more terms here to talk about. So number 38, adjacent angles. All right, adjacent always means side by side or next to, right? So adjacent angles are just two angles that have a common side and a common vertex. And another requirement is that these angles do not overlap, right? So same side, same vertex, but will never overlap. So let's see. So maybe we'll start with something like this. Okay, I'm going to break this into two parts, and I'm going to call it angle 1 and angle 2. So angle 1 and angle 2 are adjacent, right? They share the same vertex, or I'll do it in yellow at this point. they have the same side that's in green, right? They both share that side, and they don't overlap, right? So let's take a look at what an example, a non-example would be, right? Maybe I have this blue angle, I'll call it angle 1, and this red angle. So this whole thing is angle 2. Well, hopefully you can see that the red angle is actually over top of the blue angle, right? Because those overlap, these would actually not be an example of adjacent angles. Okay, and so they share a side, they do share the vertex, but they overlap. How about if we saw something like this? Oops. So let's call this angle 1 and angle 2. Well, in this case, angle 1 and angle 2, they definitely do share the same side, right? But they don't have the same vertex, right? The vertex of angle 1 is up here, call that point A, and vertex of angle 2 is point B. So for that reason, those two also are not adjacent. Okay. The final two, and again, we're going to have an entire section dedicated to these two. Vertical angles, okay? Vertical angles are just a pair of angles formed by two thought I had a highlighter, by two intersecting lines. So let's draw it. So let's draw two lines, maybe intersecting like this. I like to think about these as X problems. So you can see that the angles are formed and they kind of make an X, right? They're just two lines intersecting, a pair of angles across from each other. So non-adjacent, I'm going to even write in here across from each other. Those are examples of vertical angles. So maybe we have, angle 1 and angle 2. Actually, let me do this. So angle 1 and angle 2. We know that these are always going to be congruent to each other. And we might be getting ahead of ourselves a little bit, but we can draw that in. For now, the important thing is to know that angle 1 and angle 2 are vertical angles, but then maybe we call this angle 3 and angle 4. Right? So in this case, there's actually two different pairs of vertical angles that are formed. Okay, so all you have to know is they're across from each other in the X. And then finally, so linear pair. They're a pair of, this time, adjacent angles, or next to each other. So I'll put next to, right? That's what we said adjacent angles were. This time, we know that they're always going to be supplementary, right? Hint, hint, that was another vocab term. So if you don't remember what that is, scroll up, get number 37. Right? They're just two angles that will together add up to 180. So a linear pair, let's start with a line. We make two angles out of it, angle 1 and angle 2. We know that together, angle 1 and angle 2 are linear. They're a linear pair, and together they will always add up to 180 degrees. So maybe we even say angle 1, plus angle 2 equals 180 degrees. That's what's important here. And then actually, again, we're getting ahead of ourselves a little bit here, but we can say that for vertical angles, they're always going to be congruent. So angle 1 is always congruent to angle 2, and angle 3 is always congruent to angle 4. Okay. All right, guys, I know this was a bunch of terms here, but thank you for watching and hanging in there with this. Again, we're going to have some time to practice. Hopefully some of these were familiar to you before, and maybe some are new. I'm sure there are a few. But again, we're going to have time to practice this. Let this settle in. Try some of the practice problems and see how you can do. Refer back to this chart, right? Keep using this. That'll help it kind of commit to your memory. So thank you for tuning in, again, for watching this whole thing. Let us know if you have any questions while you're working. But again, hopefully this helped, and good luck with the practice.